Okay, we're going to take a look at another one. This one we're going to look at number 91. The line segment AC has endpoints -1, -3.5, and 5, -1. Point B is on the line segment and is located at 0.2, -3. What is the ratio of AB to BC? So let's get the whiteboard opened up. I know how to do that. I just did it in the last video. All right, hold on. Okay. So once again, oh geez, this is going to be a thing. I should have written this down. Hold on. Oops, there's the answers. -1 to -3.5, 5, -1, and 0.2, -3. A, C, B, and I want to know AB to BC. Okay. So now I will be able to open up the whiteboard. There we go. So we have our coordinate plane again. I'm going to do my best to draw it as nice as possible. And we have points at -1, -3.5, 1, 2, 3, 4. So right about here. That's -1, and then halfway in between -3 and -4. C is at 5, -1. So 1, 2, 3, 4, 5. -1, which is right about here. And B is in between. So let's go ahead and first of all connect those. And B is at 0.2, -3. 0.2, -3 is like 1/5 right here. Okay. So it wants to know the ratio of AB to BC. Now I drew that picture just to kind of give you an idea of what we're doing. You just need to find the distances of these points and then divide them. AB is this distance, right, from here to here. And then BC is this distance from here to here. Now you guys have the distance formula, hopefully. It's, square root Pythagorean theorem, essentially. So I'll go ahead and do that for you. On this one goes over here and then down. I'm just going to do Pythagorean theorem. That distance from -1 to positive 0.2 is 1.2. From -1 here over to positive 0.2 is going to be a distance of 1.2. And from -3.5 up to -3 is going to be 0.5. So essentially what we have here is we have a triangle that is 1.2 on this side and 0.5 on this side. That's because that's the difference between -1 and 0.2 and -3, 0.5 and -3. It just, you count that distance essentially. Then you do the Pythagorean theorem with that. 1.2 squared plus 0.5 squared, and you get 1.69. So the square root of that is 1.3. And now I'm going to use that same process to find this length, because again, remember, I'm just comparing two lengths. Here we have like this to this. It's not exact. You guys know that drawing here is kind of tricky, but it's okay. Then we have to do the same thing where we pay attention to our distances so that we can do Pythagorean theorem correctly. This goes from 0.2 to positive 5. Starts at 0.2 to positive 5. So that's going to be 4.8. You just have to count that distance. And it's going to go from -3, the y value, up to -1, the y value. So that'll be a distance of 2. So again, we do the same thing with the Pythagorean theorem. We do 4.8 squared plus 2 squared equals 27.04. We take the square root of that. And we get 5.2. So this length right here is 5.2. So now it wants to know the ratio of AB, which is 1.3, to BC, which is 5.2. Ratio just means divide. 1.3 to 5.2 would be 1.3 divided by 5.2, and you get 1/4. So that is the ratio. So this little line segment AB is 1/4 the size of BC. So these questions are mostly about distance. Then once you find the distance, you divide them in whatever ratio it wants. So that was number 91.